Hello, we're going to review your MT4 LT9 affirmation right now. And when you do the MT4 LT9 affirmation, I'm going to review some of the parts from the seminar that maybe you didn't understand when I reviewed them or you forgot. The first one, I want you to list all possible rational zeros for the following polynomial. The rational root theorem says this: if you take all the factors of your constant term, which we're going to call P. So now I'm going to take all the factors of my constant term, that's going to be P. And I divide that by all the factors of your leading coefficient. In this case, the leading coefficient is 4 because it's to the x to the fourth power. Then that's going to list all your rational roots. So let's list them out. P, all the factors of P. Well, plus or minus 1, because it could be positive or negative. Plus or minus 2. I don't know why my negative sign kind of looks weird there. Let's try that again. Plus or minus 2. Plus or minus 3. And plus or minus 6. All the numbers that are factors of 6. Q is going to be plus or minus 1. Plus or minus 2, plus or minus 4. So I'm going to list them all out now. So now we're going to list P over Q. Well, if I take everything divided by 1, because I'm taking P divided by 1, I'm just going to P, aren't I? So I'm going to get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now the second one, I'm going to divide by 2. So I'm going to get plus or minus 1 over 2. Plus or minus 2 over 2, well, that'd be 1. I already listed 1. Plus or minus 3 over 2. And plus or minus 6 over 2, well, that will be 3, which we've already listed. Now I'm going to divide by 4. So we get plus or minus 1/4. Plus or minus 2/4 would be 1/2. Already got that. Plus or minus 3/4. And plus or minus 6 over 4. What 6 over 4 reduces to 3 over 2. So we've got that. So here are all of the possible rational roots in this problem. So P over Q. You should have listed them all out. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2. Plus or minus 3/2, plus or minus 1/4, plus or minus 3/4. And 30 years ago, or 40 years ago, when I was in high school, we'd have to take synthetic division. We'd have to try each one of these to see if it worked. It's kind of a pain in the butt. Luckily for you, you don't have to do that. Now, the conjugate theorem. It says for a polynomial, f of x with a degree of 3 with 3 real coefficients and has the following zeros. One of them is at negative 4. One of them is at negative 3 plus I. And by the conjugate root theorem, it says, hey, if you have complex numbers, they come in pairs. 1 plus bi and 1 minus bi. So I've got negative 3 plus I. That means another factor would be negative 3 minus I. So in other words, I'm going to multiply these together. I'm going to say x minus a negative 4 times x minus negative 3 plus I times x minus negative 3 minus I. Well, I can simplify that a tad. I'm going to go, that'll be x plus 4 times x plus 3 minus I times x plus 3 plus I. Now, we're going to multiply these three together. Well, here's what I'm going to do. I'm going to think of this as x squared minus, or a squared minus b squared. In other words, I'm going to say this is going to be x squared I think I'm just going to show this the old-fashioned way. Kind of going through this. So in other words, let's take x plus 3 minus I times x plus 3 plus I. And since there's three terms, I think I'll use the box strategy to multiply these three terms together. It's just a strategy to help me out. So I'm going to go x plus 3 plus I, x plus 3 minus I. I'll multiply those two together. So you get x squared plus 9 positive xi, and I'll take 3 times everything, so I'll get 3x. Oh, I put the 9 in the wrong spot there, didn't I? Sorry if that confused you, because it's 3 times x. And then 3 times I is 3i. Then I'll get negative ix, negative 3i, and negative I squared. Now let's write down what we have. We have x squared plus 6x. Notice the xi's and the negative xi, they cancel each other out, don't they? So xi and negative xi, they cancel. 3i and negative 9i, or negative 3i, they cancel. So we've got plus 9 minus I squared. Well, remember, I squared is negative 1. So this is x squared plus 6x plus 9 plus 1, or x squared plus 6x plus 10. Now, I'm going to take that answer, I'm going to multiply by x plus 4. So I'm going to change colors here. So I'm going to take an x plus 4 times x squared plus 6x plus 10. I'll use the box method here also. So I'm going to go x squared plus 6x plus 10. I'm going to multiply that by x plus 4. So we get x cubed plus 6x squared plus 10x. And I'll get 4x squared plus 24x plus 40. Too much coffee this morning. My hands are shaking. So we get x cubed, 4x squared plus 6x squared. Well, that's 10x squared. And then we have, forgot my x there, I just noticed. 24x plus 10x is 34x plus 40. So that is your polynomial that has those roots. X cubed plus 10x squared plus 34x plus 40. And finally, the last question. You did partially right. The function below has at least one rational zero. Use this fact to find all of them. And here's the problem. You found some of the answers through Desmos, I'm guessing, but you didn't find all of them. But let's use the fact that what you did to help find all of them. Because now, we use Desmos, you graph that, and it looks like it crosses at -5 and -1. But by our theorem says if I have something to the 4th power, I have up to 4 real roots. Some of them might be repeated. This might be all of them. But in case this case it isn't. So here's what we're going to do. We're going to take our root of -5. We're going to use synthetic division, and we're going to show that it is a root. Although you knew that from graphing, we're going to use that answer to do the next one. So 3x to the 4th, 16x cubed, positive 4x squared, negative 4x, and positive 5. Since it's a root, I should get a remainder of 0 here. So let's do that. Bring down the 3. 3 times negative 5 is negative 15. 16 minus 15 is 1. Times negative 5, well, that's negative 5. 4 minus 5 is negative 1. Negative 1 times negative 5 is positive 5, which is 1. 1 times negative 5 is negative 5. I get a root of 0. Now let's do the same thing for your second root, which is negative 1. And this time when I do it, I should get a 0 for remainder here. Bring down the 3. 3 times negative 1 is negative 3. Plus 1 is negative 2. Negative 2 times 1 is positive 2. Negative 1 plus 2 is 1. 1 times negative 1 is negative 1, and I get 0. Now remember, this is the depressed polynomial I talked about in the seminar. You started with x to the 4th power. So when you found the first answer, that was x cubed. When I found this one, this was x squared. So now you've got x squared, or 3x squared, minus 2x plus 1. We know that equals to 0. You can't factor this. You could try, but it won't factor. So now we're going to use our handy-dandy quadratic formula. That's where we're going to get our complex, our irrational roots. So we know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, the opposite of negative 2 is positive 2, plus or not minus b squared, which will be negative 2 squared, minus 4 times a, which is 3, times c, which is 1, all over 2 times 3. Now we're going to simplify that. Whoops, extra mark there. So I get 2 plus or minus 4 minus 12 all over 6. Then I'll simplify that a little bit further. 2 plus or minus negative 8 all over 6. Now we'll make a factor tree. We know we have an I. I know it's 2 plus or minus I times the square root of 8 all over 6. But the square root of 8 I can rewrite as 2 plus or minus I times 2 square roots of 2 all over 6. And once again, how do I get that? Well, I went over here and made a factor tree. 4 times 2 is 8. The square root of 4 is 2. That's where you get that 2 radical 2. Now I'm going to rewrite this with a common denominator. I'm going to write two fractions. So I get 2 over 6 plus 2i square roots of 2 over 6. That's usually how I like to write the number, then I. Now I can reduce 2 6 to 1/3. And 2 goes into 6 also 3 times, so I get I square roots of 2 over 3. Most of the time you'll see it written as 1 plus I square roots of 2 all over 3. But you can write it the first way too, and I think that might be easier to type in into Alex when you're answering this question. There was a lot of work on this little quiz, wasn't there? Okay, so now the redo is open for you. Let's complete that. If you get less than 84%, take a picture of your work and send it to me. If you get more than 84%, just hand it in.